Hi everyone, welcome to Vishwablooms. So in this video we'll be looking at optics. So let's see. So as many of you are asking for ninth class optics, okay, so I have been I'm resuming it today. So see Sumant TV and many of you have asked previously also, like Pavitra and Rangoli Soumya. So I'm going to resume it again. So today we are going to look at the second concept of optics, class 9 physics techno. So welcome back. So this concept is actually very simple concept. Okay, nothing to worry much about this. It's a quite simple one. Okay, you'll have one single formula and yeah, you will be done. Very simple. Okay, so let's get into it. It's a very small talk concept. So first and foremost thing which we'll be discussing in this concept will be total internal reflection, that is TIR. So first we will come to the classical definition of this and then we will move on to the explanation part. Okay. So first we will look at the definition which is given. The phenomenon due to which a ray of light while traveling from an optically denser to optically rarer medium gets reflected into the optically denser medium at the surface of a separation is called total internal reflection. Okay, so in this definition, what are the key words? First we will understand them and finally we will understand what is total internal reflection. See, a phenomenon due to which a ray of light while traveling from optically denser medium to optically rarer medium. So which is the denser medium here? Obviously this is the optically denser medium and the outside one will be the optically rarer medium. Okay, so this is very important, and this ray of light is traveling from the optically denser medium. So I am assuming that it is traveling from here and that is the ray. Okay, so this is the ray. Okay, so as it is coming from the optical denser medium to optically rarer medium, this is the rarer medium, right? Okay, and it gets reflected into optically denser medium at the surface of separation. See, now what is surface of separation? That term is to be noted here. Okay, so this is the surface of separation. Okay, because at this point here you will be having denser and here you will be having rarer. So these two surfaces or media is getting separated by this surface of separation. Okay, that is called as surface of separation. So what he is trying to tell is, when it is trying to travel, a ray of light is trying to travel from the denser medium to a rarer medium, but it is getting reflected into the optically denser medium only. Okay, this is the optically denser medium. So it is actually trying to get into the rarer medium, but it is getting back reflected to the denser medium. Okay, at the surface of separation, at this surface of separation. That's it, nothing much. Okay, it's very simple, right? Yeah. Now let's look at the next part of this, that is critical angle. Critical angle is very simple. The name looks so critical, but the topic is not that critical. Very simple. Okay, so angle of incidence in a denser medium, for which the angle of refraction in a rarer medium is 90 degrees. So first, as you can see, I have marked here, this is the denser medium which I have taken, and the outside world will be the rarer medium. Okay, so the angle, let me assume the angle to be theta. Okay, this angle theta of incidence, this here it is incidence, right? This is the incidence angle, for which the angle of refraction is 90 degrees. So here, as it is going in this way, the angle of refraction is 90 degree. So in that, for which that theta is called as critical angle. The angle for which the refracted rays angle will be 90 degree. Okay, the angle of incidence for which the refracted rays angle will be 90 degree. That's it, very simple, right? So this theta will be varying from substance to substance, because as we change the denser medium or the denser medium, the theta will be varying. Okay, theta will be varying. So I hope this part is clear to you. And next we have to see very important two conditions for the total internal reflection. That is the TIR conditions we are going to see now. So there are mainly 2 points. So the first point, first we will see what is the point. Rays of light must travel from an optically denser medium to optically rarer medium. So in the first diagram itself I have shown you, right? And in the definition also we understood that the ray of light, it should be traveling from the optically denser medium to optically rarer medium. That is the essential condition for the total internal reflection. Understanding? Next we will see the second point. The angle of incidence in the optically denser medium must be greater than the critical angle. So wait, this point seems to be very confusing. Maybe I will explain you. So angle of incidence in the optically denser medium must be greater than critical angle. What is critical angle? For the reflection angle, like theta c is actually represented for the critical angle. Okay, it must be greater than that. What we have seen the critical angle definition just now, that means it should not be 90. Indirectly he is giving in explaining it. Okay, the angle of incidence, if it is lesser than this also, it will be very smaller, right? It should be greater than that in order to have total internal reflection, so that it will come here. Okay, so I hope it is clear to you until here, right? These two essential conditions. Now we shall see the relation between the refractive index and critical angle. So I am going to derive the relation, okay, between the refractive index and critical angle. So first what are we doing? We are going to consider a ray of light, that is AB. This is the ray of light. Okay, so it is traveling from the, this is actually I told you, this is optically denser medium to the optically rarer medium. Okay, such that the angle of refraction in the optically rarer medium is 90. So in this way it is actually going. Okay, here the angle of refraction is 90 degree, angle of refraction. Okay, and in such a way that ABM is the critical angle. So if the refracted angle is 90, then this is the critical angle we already studied just now, right? So this is the, I'm considering it to be C. So this is the case now. So what I can tell, angle ABM, that is nothing but I'm considering it as C. This is the critical angle. That is clear to you, right? This part. Okay, now we are going to make out the relation between refractive index. First what we will do is we will try to find out the refractive index of 1 with respect to 2. Okay, so refractive index of refractive index of 1 with respect to 2. So this will be equated to the Snell's constant, you know, right? Snell's law, sin I by sin R. So in the first concept also I have discussed about the Snell's law, right? So what it states, the sine of angle of incidence is to the ratio of sine of angle of refraction is a constant. That is what Snell's law actually states, right? It is also the law of refraction. So we have already studied that. So that only I am applying here. Okay, that is it. Next, here I am going to write it as mu, that is angle of refractive index of 1 with respect to 2. Here angle of incidence we have considered it to be C just now. Here in the diagram it is C. So I am going to take it as C by, what is refracted ray? Refracted, that is refracted angle is 90 degrees. So I'm going to directly write it as sine 90. Okay, so that is it. That is the relation. Very simple, right? Now if I have to find out the refractive index of 2 with respect to 1, how would I do that? Simply we will reciprocate this. Okay, we are going to reciprocate it. That is 1 by mu, that is refractive index of 1 with respect to 2 will be sine 90 degree by sine C. So on reciprocation this turns to this. Okay, it will get reversed. So that will be simply sine 90 by sine C. Okay, this clear to you? Then it will be perfect. Okay, now sine 90 value you can substitute, right? It is 1. So I'm going to do that for you. So mu2, that is refractive index of 2 with respect to 1 will be 1 by sine c, that is the angle of incidence, and refractive index of 1 with respect to 2 will be sine c by 1. So now you can solve many problems using these formulae, right? There are problems in the questions based on this formula only. So I hope you understood the derivation. It's very simple one, right? So in the next case, actually we have few theory part, actually most much of the theory. So let us see that also. I'll be trying to explain it. Actually, if you read it only, you will understand that simple it is. So the consequences of total internal reflection. So where actually you can see this. So, okay, due to the total internal reflection, firstly you can see that the air bubble, whatever is there in water, appears shining. So this bubbles, whatever is there, will appear shining, and due to this total internal reflection only, the diamonds whatever are there, it is going to get glittered. Okay, and mirages are formed. The images are formed in cold countries due to looming. The upper surface of water contained in a glass beaker and held above eye level appears silvery. So these are all the consequences when you keep when you have a glass beaker and the upper surface of the water appears shining, like when you hold it above the eye level, right? So that is about the consequences of total internal reflection. And next you have something called as optical fiber. Okay, so optical fiber is actually a topic which you'll be studying to your intermediate or the PUC, or if you're studying in 11th and 12th CBSE. Okay, so it's actually a very important and useful branch for physics. Okay, so in this optical fiber, what is the key principle, basic principle is this total internal reflection. You will be studying about this more and more detail in your higher standards. Okay, this is whatever we are studying is very basic. Okay, so what generally this optical fiber comprises is this fiber. It's a very thin. Okay, it's actually made of some glass or some kind of plastic. Okay, and it will have the radius very small, that is micrometer of size. Micrometer, what is micrometer factor? Submultiple factor is 10 power minus 6 meter. So that is very small, and these optical fibers are used in many fields, like in communication they'll be using transmissions and all that. Okay, so in so many investigations like medical investigations and all that, so it is very essential thing only, this optical fiber. It will be used for measuring the temperature, pressure, and also it will be useful for uh, many sensors and many things. Okay, we are actually using these, but you will be learning about this in the higher standards very detailedly. So there are some theory points you will be, if you read that, you will be able to understand it very quickly by solving the questions also, because that's very simple. So I hope you understood this class very well. So thanks for watching our video. Do like, share and subscribe to Vishwablooms. Bye bye.